The first method is fast gradient sine method. So far, anybody have any doubts? If everything's fine, then I can move for the next one. Okay, great then. So so the first one which we are going to see about is FGSM, fast gradient sine method. This is an attack. What they are trying to say here, they're making some small change in the direction of the gradient sine to the input. The input is the image. We have the image. We add some gradient sine in the input. Along with that, we are sending it to the AI model, whether it can be recognize it or not. Okay, what happens here? Here, for a normal person, like as a person, we will not be able to recognize that. There is no changes. Like see, both are looks like a parrot. There is no change in that. Okay, they have added in small pixel level. They have added into that picture. Once we combine these two things and send it to the AI model, whether it can be able to find it or not. Okay, in that case, what happens? It will detect that as a wrong one. Okay, it says it's not a parrot, it's a ostrich, it's a something called, it's a volcano or something. It has something different. Okay, what we are trying to do here is we are making a small mathematical tweak here in that picture. Okay, the image still looks for everyone, it's the same. There won't be any changes will be present, but the model makes a completely wrong predictions. Okay, so we will see how this can be done. Okay, we will see that's a practical one. So before that I want to explain the code to you how that works. So we are not going in depth detail of the code, since this is a like high level we are going to see. Here I add that image path. If you see that the import full box as FB, this is the full box tool. So we have written a code. In this code, we take the input as an image. We use the model called ResNet 50 model we have used, and the attack which we are going to perform is the FGSM attack. See here, the first one is the image, the signal image, name of the image which we are going to give as input, and the model which we are going to test is the ResNet 50. Whatever model if you want, you can test it by your ResNet or maybe like mobile Excel, and so many models are there. You can check what models if you want to test for that. So the attack which you are going to provide is FGSM. Okay, let's see the practical. Okay, Mukesh, please share your screen. Okay, so this is the practical one. This is a program which we have written to use the tools and take the inputs and the model. This is a backend page. So future we will be able to create a front ends as well. Okay, full box as AFP we have declared here. Okay, you can move down. Okay, so now we use the model dot ResNet 50. If you see that the model which we have used, we are loading the pre-trained model here. That is called ResNet 50. Then we just wrap the model in the full box interface. For that we use PyTorch model. Okay, then we directly predict the original label. Later we attack the FGSM. Right? We are using the FGSM attack. Attack equal to FB. FB is the full box. In that we have a lot of attacks. In that attack, we use the FGSM. That is fast gradient sine method. Okay, these are the main things in the input and the attack. We are collaborating in a single program. Okay. Okay. Now we are going to execute it. Okay, you can execute. Okay, so we have execute. See, this is the output of the image. So image, virtual image, which we have provided here is this is the original image to the AI model. Okay, the model name is ResNet 50. We have provided the model, but the model is not resistant to that attack for the FGSM attack. Okay, see here, this is the original image. The right side you see the adversarial image. Its success is true. What it represents means the attack is success. Okay, here we have added some tiny changes. If you see in the bottom, the left side, if you see the output, the original label is 632. The adversarial label goes for 920, and the attack success rate is, it says it's a true. Okay, so in that way, the attack has been success. So this is how the FGSM attack is executed. This model is failed for a FGSM attack. So anyone has any doubt here? Fine. So I'll with that we will move for the next attack. Okay. So far we have seen this attack. The output